Um, so if I have different products, and let me add another product named perhaps video game, right? So I can go here, say view my projects, go to my package and create another Java class and say this is a game or video game as it was appearing there. So when I finish it, I can also specify that maybe it has another attribute. I can make my attribute private, and that attribute might be a version, right? A version of the game, and therefore I need a public constructor for video game class, and that video game class, and by the way, of course, it also extends the product, right? So we extend that, and video game constructor takes my version, maybe another string. That's okay. Another string, and I'm going to say string version. Okay, and right there, just like with the book, I still need, if you compare it with the book took the name, and it also took additional attributes or additional parameters that the class needs to initialize its object. So therefore, I'm going to do exactly the same thing. I'm going to need the name parameter as well as the version. Of course, the first statement in this constructor should be a call to the superclass constructor. Just like with the book, it passes the name to the superclass, and so product has a chance to initialize its name attribute. Then I will say that this version right here equals version that was passed to as a parameter to this specific constructor. And then I can also do my own version of a full description. In fact, I can copy and paste this full description from my book class, right? So it's very similar. So full description of the game will be the name of the game plus version, right? So it's different. It doesn't have the ISBN. Instead, it's using a version. This is fine. One note is that since full description was originally created inside the product class and was declared there as public string full description, and we're trying to provide specific versions of the full description, we know it's going to be successfully called from different situations where we have a parent class or superclass and subclass, and even if we use superclass reference to a subclass, the specific version of the method will be invoked. That's part of the runtime behavior of this in this particular situation. Then it actually makes sense to say override explicitly, right? To add an annotation, Java annotation to these methods. This is highly advisable practice to do something like this. In fact, when we work with the product and we redefine equals method, we also use this because this is very much advised practice to use when you write your code. So I wouldn't be surprised if some environments would actually have certain settings which would force you to use override, or you will see errors even in your IDE environment. But Anyway, you won't be able to compile if override really doesn't, if override's check really kind of fails. So anyway, override is your huge friend. It's really eliminates unnecessary little bugs that are sometimes very difficult to find. Okay, so we have the override, and then we can make one step further and say, we really don't want to construct products. We only want to construct game objects or book objects. Therefore, if we are not planning to construct any product objects, then we can simply say that we would like to remove implementation of full description from the product. This way, you can do it if you say abstract. Right? If you declare this method abstract, you can then declare it like this, eliminate the implementation entirely, and declare it as abstract, requiring all derived classes to provide implementation of full description. Right? Perhaps this is a better choice rather than have a method which has some implementation but will never be used simply because we have no intent of creation of a product. Because notice that in main, anytime we want to use product reference, this is fine. But when we say new, we actually create a specific product. Right? Actually, over here we did create product, so this time this will fail. If I save this, as soon as you add a method which you declare to be abstract in your class, which means that its implementation is supposed to be provided by classes that derive from this class, two things happen. Number one, you can no longer instantiate class name product. Java actually requires you specifically declare it by saying that the class itself is abstract. Okay? And this is how you do it. You say this is no longer a regular class, this is an abstract class, and it means that you cannot say a new product anymore. You can only say new something which derives as a subclass of this specific superclass in our situation, right? So the product is a superclass. So here we intend to create a couple of products here. So let me change this to be a game, right? We can say video game right here, and we can say video game right there, and we can, I don't know, racing game and a puzzle game, right? We can create those two games. However, we also need a version. Now, sometimes you can have more than one constructor, and very likely that interesting classes will have more than one constructor. So for the video game, let me actually implement a shorter version of the constructor. I will say video game can have a constructor without specifying the version, and in that case I may delegate the work to another constructor using this keyword and say use another constructor which will take the name, and for the version then I will use a default value such as 1.0. Okay, so if this arrangement is made so that you have a constructor which takes a shorter list of parameters that you would normally need to initialize your class, then you can forward the work to another constructor using this keyword. So notice that we were able to call a superclass constructor using the super keyword, but besides that, you can also delegate the call to another constructor, from this constructor to another constructor, by using this keyword. It's also simply just delegates the call to this constructor and adds a default parameter such as version 1.0 to the whole initialization process. Okay. So by doing this, I'm simplifying my efforts here so that now I can create those video games and do not specify the version, knowing that it's going to print the version anyway. So just to give you an example. But since the product is made abstract, I can no longer create new product. And you could see that I kind of forced myself to change to a specific type of class right here. This used to be a product. It's no longer available for creation directly because the class is named abstract. So what abstract class value is for us? What kind of value it gives to us as designers of our software? We basically would like to provide pieces of interface, right? Full description is definitely something that we need for every product. However, we cannot. We decided that it's just being an overstatement to add the actual implementation to the product class. So instead, we're adding implementation to each specific class that we derive from our product superclass, and then provide the actual implementation. So that happened in both the video game right here and the full description. So just in case, let me just make sure that it's all runnable and does something. So it still runs. This is fine. And compiles properly. So I just wanted to check the syntax. So this briefly gives you ideas about the syntax of abstract methods, and also the fact that to explicitly indicate that you can no longer create class named product, only its sole purpose is to serve as a superclass for specific classes which will be derived from it. And so this is why you also need to add an abstract keyword to its definition, to its header in your class definition. Okay, and so this is what we have here as a topic.